Let us solve this problem where we have to find the absolute maximum and absolute minimum values of the function f of x, that is equal to negative of mod of x minus 2 plus 4, where x belongs to the set of real numbers. So from this function we can easily see that the domain of this function is the set of real numbers, right? And the set of real numbers can also be written in the form of interval, that is x belongs to minus infinity to infinity, right? So we can write this statement as x is greater than minus infinity and less than infinity. So here we have the real number line, here we have minus infinity, here we have plus infinity, and here we have say 0, right? So the domain of this function is the set of all real numbers, and x belongs to R can also be written like this: x belongs to negative infinity to infinity. That is this statement can also be expressed like this: x is greater than minus infinity but less than uh, infinity, right? So now here we have x minus 2. So let us subtract 2 throughout this inequality. So when we subtract 2 from minus infinity, we again get minus infinity. Here we have x minus 2, and when we subtract 2 from infinity, we again get infinity, right? So when x is greater than minus infinity but less than infinity, then x minus 2 is also greater than minus infinity and less than infinity, right? So now here we have mod of x minus 2, and from the definition of mod function, we know that the mod function gives us always gives us positive numbers or the quantities, right? So here we can now write mod of x minus 2 must be greater than or equal to 0 but less than infinity, because x minus 2 is greater than minus infinity to plus infinity, right? So it is greater than minus infinity but less than infinity. So mod of x minus 2 must be greater than 0 or equal to 0 but less than infinity, because here we have all the positive numbers, right? So this is an important step here, that is mod of x minus 2 is greater than or equal to 0 but less than infinity, because the mod function gives us the positive numbers, right? So now here we have a negative of mod of x minus 2. So let us multiply this inequality by negative 1. So when we multiply this inequality throughout by negative 1, then the direction of the inequality gets reversed. So here we have 0, here we have negative of x minus 2, and here we have minus infinity, because here we have plus infinity, right? Okay, so now we can also write this inequality as negative of x minus 2 is greater than minus infinity but less than or equal to 0. And here we have plus 4. So let us add 4 throughout this inequality. So we have when we add 4 to minus infinity, then again we get minus infinity here, and here we have minus mod of x minus 2 plus 4, and here we have 0 plus 4 is 4, and here we have minus infinity, and this is our function negative of mod of x minus 2 plus 4 as f of x. So here we have f of x, and here we have 4, right? So from this inequality we can draw the conclusion that f of x is greater than minus infinity but it is less than or equal to 4. So now from this inequality, we can easily conclude that the absolute maximum value of this function when x belongs to R is given by 4, because f of x cannot go above 4, right? So the absolute maximum or the global maximum of this function is equal to 4, because f of x cannot go above 4 for any x belonging to R, and here f of x is greater than negative infinity. So from this inequality we can conclude that this function does not have any absolute minimum. That is, the absolute minimum value of this function f of x, it doesn't exist, right? So the absolute maximum is given by 4, and the absolute minimum value does not exist, right? So this is how we can find out the absolute maximum and absolute minimum values of the functions of these types.